everyone. Let's try another one of those stoichiometry problems. So here we have a word problem. The Haber process for the production of ammonia is represented by the unbalanced equation N2 gas plus hydrogen gas makes ammonia gas. The complete conversion of 9.0 moles of hydrogen to ammonia would require how many moles of N2? So let's start by balancing this equation. We have N2 plus H2 makes NH3. Now, hopefully one of the first things you notice is that we have the odd-even rule here. We have an even number of nitrogens on the reactant side, an odd number on the product. We have an even number of hydrogens on the reactant side and an odd number on the product side. So how do we make an odd number even? We put a 2 in front of it. So let's put a 2 in front of the ammonia, and that will give us 2 nitrogens on the right-hand side, and 2 times 3 is 6 hydrogens on the product side. So let's balance this. So since we have 6 hydrogens on the product side, we need 6 hydrogens on the reactant side. So let's put a 3 in front of the hydrogen. So that gives us our 6 hydrogens. And we have 2 nitrogens on the reactant side. So we are balanced. So now that we have it balanced, let's get started in finding the answer to this problem. So we're starting off with 9 moles of hydrogen. So let's put 9 moles hydrogen is what we're starting off with. Let's make a conversion factor. These are very similar to the conversion factors we used last semester when we were talking about going from grams to moles or moles to grams, okay? And if you remember, in our conversion factors, we want to put what we want to get rid of on the bottom. So we want to get rid of moles of hydrogen. And we want to put what we want to end up with on the top. And if you look at the problem, they're asking how many moles of nitrogen. So let's put moles of nitrogen on the top. So what we have here, we have moles over moles. That's called a mole ratio. And we need to figure out what numbers to put in our mole ratio. And this is why it's so important to understand how to balance equations, because the numbers you put in the mole ratio come from the correctly balanced equation. So we have moles of nitrogen on top, and the number that goes here is the coefficient in front of nitrogen in our balanced equation, which is just a 1. And we have moles of hydrogen on the bottom, and that comes from the coefficient that's in front of hydrogen. So we put a 3 there. All right. Now that we have that mole ratio, we can go through and see if we have any units that cancel out. It's so important to watch your units. So moles of hydrogen will cancel out. So what we're left with is moles of nitrogen, which is what we want. And we have 9 times 1 is 9 over 3, because 3 is in the denominator. So our answer is 3 moles of nitrogen. So 3 moles of nitrogen would be required to completely convert 9 moles of hydrogen to ammonia. Now, if you didn't want to use the mole conversion process, which I think is the better way to do it, you could just do it the way where you just look at the ratios and you come up with the number that you multiply by. I'm going to leave 3 moles nitrogen there to show you that to remind you that we're going to get the same answer, okay? So we want 9 moles hydrogen. So we want to have 9 moles of hydrogen here. Now, to get from 3 to 9, that means we need a multiplier of 3. So we have to use a because we have 9 divided by 3 equals 3. So our multiplier is 3. So if we use our multiplier of 3 times our nitrogen, we come up with 3 moles nitrogen, which is the same thing. All right. Hope that made sense. And if you have any questions, feel free to email me. Bye.